So good morning to all of you. I am Archit Priyadarshi and my registration number is 25BAI1475. So today we're going to see hashing. So we'll start with introduction to hashing, then we'll see hash table, division method. Basically, division method is an insertion method uh, through which we can insert elements in a hash table using division approach. And then we'll see collision and some techniques to resolve those collision. And at the last, we'll see the applications of hashing. So let's get started with the hashing. So hashing is a technique used to store and retrieve data efficiently. Average search time complexity of hashing is O(n). Basically, in most of the data structure, the time complexity is O(n) or O(n log n). So hashing is quite efficient in terms of searching. That's why we are using this type of data structure. Basically, it maps a key to a specific index in a hash table using a hash function. So what is hash table? A hash table is a data structure that stores elements using key index mapping. The index is generated using a hash function. Such example of a hash function is 2k plus 1, where k is the key or the element. Now we'll see the division method. So the division method is a simple hashing technique used to determine the index in a hash table where a key will be inserted. And its formula is key mod m. So basically, key is the elements which is need to be inserted. M is the size of the hash table, and mod is a modulus operator, and hk is the index of the hash table. For example, if we have to insert 23 in a hash table of size 10, so 23 mod 10. So the mod operator gives a remainder. So when 23 is divided by 10, it will give 3. So 23 element will be stored at the index 3rd of the hash table. So now we will see the collision concept. A collision occurs when two different keys map to the same index. Suppose we have two elements, and when we divide that element by the size of the hash table, and we'll get the same remainder. This time, at one index these two elements will be there. So this concept is called collision. There are few methods to reduce this collision, and some of these are separate chaining, linear probing, quadratic probing, and double hashing. So now we will study about these techniques to reduce collisions. First, we will start with separate chaining. In separate chaining, each table index stores a linked list. If multiple keys map to the same index, they are stored in the list. Here is such an example of a separate chaining. So here our keys are 11, 21, 31, 27, 37, and 5. And the hash function is k%, k mod 10. So at index 1, 11 mod 10 will give 1, 21 mod 10 will give 1, 31 mod 10 will give 1 also. So at index 1, 11, 21 and 31, these three elements will be there at index 1. So we use linked list at index 1 in order to show these elements here like this. Similarly, for 27 and 37, when 27 mod 10 will give 7 and 37 mod 10 will give 7 also. So at index 7, we have two elements that are arranged in a linked list format like this, 27 and 37. And when 5 mod 10 gives 5, so at index 5, 5 will be there. And the final hash table will look something like this. At index 1, 11, 21 and 31 is there. At index 7, 27 and 37 will be there, and at index 5, 5 will be there. So this is the separate chaining technique. Now we will go to linear probing. A linear probing searches sequentially for the next free slot. And the formula we use for linear probing is u plus I mod m, where u is the original hash index, the index that we get from the division approach. That that is U, and I will vary from 1 to 3, and M is the size of the hash table. So here is a one example of linear probing. So here the elements is 12, 22, 32, 42, and the size of the hash table is 10, and our hash function is k%10, k mod 10. If collision occurs, then find the first free index using the formula u plus I mod m, where u is the original index and m is the size of table. So we have to use this formula only when collision occurs. Okay. Now our first element is 12. So first we have to insert 12 in a hash table. So 12 mod 10, because this is our hash function. So instead of k, we replaced k with 12 because k is the key, that is element, and here 12 is our first element. So 12 mod 10 gives 2. So index 2 is empty. So we directly insert 12 at index 2 because there is no collision concept till now in this question. Now step 2, we have to insert 22. Okay. So for 22, same k mod 10, which gives 2. Now here 12 is already inserted at position 2, at index 2. But this k%m is also giving index 2, that is a collision. Like at index 2 already contains 12, so collision occurs. Since a collision occurs, we will use the formula u plus I mod m to find the first free index. So here u is equals to 2 because h mod m is also giving 2 in case of 22, and here m is equals to 10, that is our size of hash table, and I will go from 1 to 3. So first we'll take I equals to 1. So u plus I mod m is equals to u is 2. First we'll take I equals to 1. So I is 1 and mod then 10, which is equals to 3. And this third index is free in our hash table. So we will insert element 22 at the third index here. Now step 3, we have to insert 32. We will follow same approach. First we will see through hash function, that is h%m, and it will give 2. Since 2 is already occupied, we will use our formula. U plus I mod m. So first we will take I equals to 1. It will give 3, but 3 is already occupied by 22. So we have to increase the value of I. So I becomes 2 now. And then we use same formula, and this time we'll get 4, and index 4 is empty also, so we'll insert 32 at index 4 like this. Now we'll go to the step 4, that is to insert 42. Same, we'll use k mod m. It will give 2, but 2 is already occupied, so we'll use formula u plus I mod m. Then first we take value of I equals to 1, it will give 3, index 3 is already occupied. Then we'll increase the value of I, we'll take now I equals to 2, and again we'll use same formula u plus I mod m, it will give 4, but 4 is already occupied. Then we'll again increase the value of I, that is I equals to 3 now. We'll use same formula u plus I mod m, and this time we'll get index 5, which is empty, so we'll insert 42 at index 5. Now this is how the linear probing works. Okay, and now we will go to quadratic probing. So in quadratic probing, the gap increases quadratically. In linear, it was increasing linearly. In quadratic, it will increase quadratically. So instead of u plus I mod m, we will use u plus I square mod m. It also reduce clustering, this probing. And we'll see another example of a quadratic. We will see one example of quadratic probing. So here we have taken elements 12, 22, and 32. Hash table is we have taken m equals to 10, and we are using same hash function k mod 10, k mod m, that and the value of m equals to 10. So the quadratic probing formula is u plus I square mod m, where u is the original index. Index we get from the division approach, and I varies from 0 to m minus 1. And now we'll start with the insertion. So our step 1 is insert 12. So normally using hash function we are inserting. Index 2 is empty, so 12 will be directly inserted into the hash function, hash table. And step 2, we have to insert 22 now. So here k mod m is giving 2, but 2 already contains 12. So here is the collision. So we'll use quadratic probing method. First we'll take I equals to 1, then we'll use u plus I square mod m. So here u is 2 and I is 1, so 2 plus 1 square mod 10, which will give 3. So index 3 is empty, so we'll insert 22 at index 3. At last we have to insert 32. So it is giving 2 also. And index 2 is already occupied by 12. So now we will go to quadratic probing approach. First we have to take I equals to 1. Then we have to solve, and it will give index 3. But index 3 is also occupied by 22. So we have to increase I by 1, and now I becomes 2. Now we will use same formula, u plus I square mod 10. Here u is 2 and I is 2 also, so I square becomes 4 mod 10. So it's 6 mod 10, which will give 6. So index 6 is empty, and it will be inserted at index 6. So 32 will be inserted at index 6. So this is the example and the method to solve the quadratic probing. Now we will go to double hashing. So double hashing uses two hash functions. First hash gives initial position, and second hash determines step size. So in double hashing, hash table will see double hashing with an example. Here the hash table is of size 10, and the primary hash function h1k is equals to 2k plus 3 mod 10, and the secondary hash function is 3k plus 1 mod 10. So according to double hashing formula, the final position is equals to the initial hash function plus I into the second hash function mod m. So we have to use this formula when collision occurs. If collision is not occurring, then we do not need to use this double hashing formula like others. So the elements we are taking here to show double hashing approach is 2, 5, 8, and 12. So first we have to insert 2. So our primary function is 2k plus 3 mod 10. So we have to work through primary function, and when collision occurs, we have to go to secondary function. So in primary function was 2k plus 3 mod 10, and the element is 2. So 2 into 2 plus 3 mod 10, which will give 7 mod 10, which will give 7. So index 7 is empty, and 2 will be inserted at index 7. Now for 5, the primary function 2 into k plus 1 mod 10, that is 2 into 5 plus 3 mod 10, which will give 13 mod 10, and it will give 3. So index 3 is empty and 5 will be inserted there. So now we'll go to insert 8. So primary function 2 into 8 plus 3 mod 10, which will give 19 mod 10, which will give 9, and the index 9 is also empty, so it will be inserted at index 9. Now we will go to insert 12. So here the primary function, that is 2 into k plus 3 mod 10, 2 into k plus 3 mod 10, which will give 27 mod 10. It will give 7. So index 7 already has 2. So 27 mod 10 and it will give 7. But 7th index is already filled with the value 2. So here is now collision. Now we have to check the second hash. The second hash is 3k plus 1 mod 10. That is 3 into the element, that is 12, plus 1 mod 10, which will give 7. Now first we have to take I equals to 1. So here the formula is 7. The formula is this: h1k plus I into h2k whole mod m. So h1k is this plus I into h2k. h2k is 7 also. So 7 plus 1 into 7 mod 10, which is equals to 14 mod 10, which will give 4. So index 4 is empty and 12 will be inserted there. So this is the final hash table and the 12 is inserted at index 4. Now this was the double hashing approach technique. At last, we will see some applications of hashing. So hashing is widely used in database, password verification, caching systems, symbol tables in compilers, and file indexing. So thank you. So this was it, and thank you very much.